Hello my dear students, this is Akash SD and welcome to the SD Physics classes. Hope so you all are doing really great. So students, in this video we are going to learn about the new topic current density. Okay, as of now we know current is a scalar quantity. Why? Because current is having magnitude, direction, but it does not follow triangle law of vector addition. But when it comes to the current density, we are going to learn that current density is one of the vector quantities. So current is a scalar, current density is the vector. Okay, so let's learn in a detail. So students, here under the current density, let's see what is current density. See, current density is defined as the amount of electric current through a unit cross-sectional area held normal to the direction of the current. Okay, so very easy, the cross-sectional area should be perpendicular or normal to the current, then current by area will be what? Current density. Okay, so let's see the important points, then we'll go into the detail there. Okay, so see under the important points, the first one, as I have told you very well, the current density is what? The current density is the which quantity? Vector quantity. Okay, after that, if I ask about here SI unit of the current density, so current per unit area, that means this used to be students ampere per meter square. Okay, after that, if we see here the dimensional formula, so dimensional formula for current density, how much is there? Current means anyhow A, and meter square means what is this? Per meter square, that means AL power minus 2. Okay students, so this thing you have to remember that. Very important, current density is a which quantity? Vector quantity. Okay, now after that we are going to see into the detail. Okay, as I have told you very well. See, case 1. So see what is this? When cross-sectional area is normal to the direction of current, then current density is given by. Okay, so what is there? I have just taken here the, let's take for example, this is the one conductor is there. Okay, and this is the cross-sectional area of the conductor. Okay, even I can draw like this here. This is the conductor, uniform cross-section. What is this? Uniform cross-section like this. Like this I'm talking about, and this is the cross-sectional area, CSA. Cross-sectional area, we used to tell here A only. Okay, and sometimes what happens that like electric current with the we used to represent with A, cross-sectional area also with A. So please be careful. Okay, so what will happen that here, students, see, this cross-sectional area is A, this also how much is there? A. And what is happening that here, let's take electric current is flowing in this direction. Okay, like this. Let's take this electric current is flowing in this direction. Okay, so if I talk about here in terms of coordinates, we can tell this current is along the x direction, and this circular cross-sectional area in which plane? YZ plane. Okay, so if I talk about here the area vector is always perpendicular to the area. So this area vector is given by A here. So here you can see very well, students, listen very carefully. Here the area is perpendicular to the direction of the current, but area vector is along the direction of the current. Are you getting very well what I am telling that here? Listen very carefully. The area, plane of the area in which plane? YZ plane. So this YZ plane is perpendicular to the current, that is along x direction, but area vector along x direction, current also along x direction. Remember that. So remember that here, whether plane of the area or the area vector, have to be very careful. Okay students, so here what is happening that here, this is the planar area is the perpendicular to the direction of the current, or we can tell area vector is along the direction of the current. So in this situation what will happen that here, this current density is given by J equal to I by A. Okay, what we can tell here, J equal to I by A. Now like this is there. Now, and after that students here, remember that here, if we want to write here the current, so this current is given by J into A. Now just multiply J into A, and as I have told you, what I have told you, the current density is a which quantity? Vector quantity. So we can tell here vector J dot A, and we can write here this I equal to J dot A. So we can write here, see, J A cos theta also. J cos theta, is it? But here theta value how much is there? This theta value is here 0 degree. This theta value how much here? Theta value is the 0 degree. Why? Because students, see here, the current in this direction, so current density is always used to be along the direction of the current. So see here, this is the current density, and after that what is this? This is the area vector. Okay, so see, So area vector is along the direction of the current density. Okay, so in this situation what will happen that here theta will be 0 degree, and directly we can write here J equal to I by A. I hope so this is very clear. Okay, this is a very normal case. If nothing is mentioned, this only we have to think. Now area is the perpendicular to the direction of the current, and angle between area vector and the current density how much here? 0 degree. Okay, this is the by default case. Okay, next one is next one, students, please remember that here. Next one, see, case 2, na, general case. See, when cross-sectional area is inclined to the direction of current, then current density is given by what is there. Okay, so now what is there? Let's take for example, now this is the, first let me draw here, let's take this is the current. Okay, this is the current, this is the direction of the current is there. Okay, and now what is there after that? There is the one cross-sectional area, but you know now the cross-sectional area is what? The cross-sectional area is given something like this. Now this is the cross-sectional area. Okay, even if I draw here the conductor, okay, so conductor is something like this is there. Okay, and like this kind of conductor is there. Okay, like this kind of conductor is there. Okay, can you see it very well? Is it? So what is happening that here in this situation, area vector in this direction, now always perpendicular to the area. Okay, so here what will happen that here anyhow we know very well the current density is along the direction of the current. So what is this? This is the direction of the current density J, and this is the area vector. So what is happening that here this is making how much angle? Here it is making here angle theta. Again I am telling area vector is making theta angle from the current density. Okay, so in this situation what will happen that here students, in this situation remember that here this J is given by I by AN. What is this? I by AN. Okay, just let me draw here into the somewhat more detail. What happens that here if I will find out the projection of this area perpendicular to the current, see this projection of area, this one here, okay, this one projection, this projection. So what will happen that here this projectional area is represented by here AN. Okay, so you know this side is A, so this side projection how much is there? This side projection is given here A cos theta, getting this side A angle theta. So this along the horizontal direction projection how much here? A cos theta. So only we can write here J equal to I by A cos theta. Okay, this is just a perpendicular projection of the area. Okay, so from here what we can tell? I can tell here anyhow I equal to J A cos theta, or we can tell here vector J dot A. Now dot product of current density and the area vector is what? This is the current. You can see here very well. Okay, so what I am telling, theta is the angle between area vector and the current density. If I talk about here plane of the area, and the current density is making how much angle is there? Now see this angle plane, and this is making angle 90 minus theta. Some of the times they may ask, they will tell in a question like plane of the area is making 30 degree with the current density, then that time theta how much is there? If this is 30, this will be how much here? 60 degrees. So have to be very careful whether the angle is given between current density and the area vector, or the angle is given between the current density and the planar area. Okay, have to be very, very careful. Okay, great. Now students, next one we are going to see this question. What is the question is there? See, very easy question. 10 ampere current flows through a 5 centimeter square cross-sectional area held normal to the direction of the current. Calculate current density. Okay, so here you may think that okay, normal means angle is 90 degree. No, why? Because here theta how much is there? Theta is 0 degree. Why I am telling you? See, this is the area. Again I am telling you because I don't want any confusion. And see, this is the current. This is the current. Okay, so here we can tell very well the current is along which direction? See, this is x direction, and this one, this area, this cross-sectional area in which plane? YZ plane. So area is perpendicular to the plane. Area, this planar area is perpendicular to the direction of the current. But if we talk about here the area vector, this is the area vector. This is the area vector. Okay. So in this situation, what is happening that here? Anyhow, this is the direction of the current density also. So J and A is making how much angle? Area vector. Area vector and J is making how much angle? 0 degree. Okay. So theta is 0 degree. So in this what we can write here directly, we can write here the current density directly. We can use the formula J equal to I by A. There is no problem. Okay, because cos 0 is 1. So what will happen that here? I is how much given here? I is the 10. After that, area 5 centimeter square. That means what you write here? 5 into 10 to the power minus 4. Why? Because 1 centimeter means 10 to the power minus 2 meter. So 1 centimeter square means 10 to the power minus 2 meter square. It will become here 10 to the power minus 4 meter square. Okay. So when you will simplify this, it will come 2 into 10 to the power 4. And what is the unit, students, here? The unit is the ampere per meter square. So whenever in the question they are telling the area is held normal, that means theta is always how much? 0 degree. Okay. Now after that, see next one. 10 ampere current flows through a 5 centimeter square cross sectional area held area vector 60 degree to the direction of the current. Calculate current density. They told na area vector is making how much angle? 60 degree. So here what is given here? This theta is given here 60 degree. Current how much is given here? 10 ampere. Current is 10 ampere. See back side. We are going correct na? I have taken here 10. Suddenly I got confused. So see 10 ampere. And after that what is given here? Area. This area. Area how much given here? 5 centimeter square. 5 into 10 power minus 4 meter square. So again we know that as J equal to, now in this situation, I by A cos theta. So anyhow 10 by how much given here? 5 into 10 to the power minus 4 into 1 by 2. So when you will simplify this, this 2 will go up, 20 by 5, 4. So 4 into 10 to the power minus 4 ampere per meter square. This A is for ampere, not for area, okay. And if I draw here the situation is like this is there. Just let me see here. This is like this is the cross-sectional area. So this is the direction of the current density, okay. And this is the direction of the area vector. Okay, and how much angle is there in this question? Theta is given here 60 degree, and we have got here the answer. Okay, J. A for the ampere. Last one, students. See the last one. What is the last one is there? See, current density through a 10 I cap meter square cross sectional area is 3 I cap plus 4 J cap ampere per meter square. Calculate electric current. Okay, so here what is given here? See, this area vector A is given, what is there? 10 I cap meter square. Current density J how much is given here? It is given here, see, 3 I cap plus 4 J cap ampere per meter square. Okay, so what we know that here, students, see, as I equal to vector J dot vector A. Okay, so what is vector J? 3 I cap plus 4 J cap dot, how much we have given here? 10 I cap. Okay, so what will happen that here? We have to just multiply the coefficient of I cap and I cap. How much will come here? 3 into 10 plus coefficient of J cap and J cap. Here coefficient 4. Here no coefficient. Even you can write 10 I cap plus 0 J cap also. So it will come here 4 into 0. So what this will come here? It will come here 30 ampere. Okay, so you can see here very well. Even in this also, if you are getting confused, even you can do like this also. Like vector J is given here 3 I cap plus 4 J cap, and the area is given here what here? 10 I cap plus 0 J cap. Okay, so like this also you can do here. The dot product vector J dot vector A is equal to what we can do here? 3, here 10. So 3 into 10, 30 plus here 4, here 0. It is 0. So what is coming here? This I is coming here 30 ampere here. Is it? Kindly see it very well. So only students, in this video we have covered very well about the current density, and make sure that the current density is the which quantity? Vector quantity along the direction of the current. Okay, and this theta is the angle between current density vector and the area vector. Okay, and 90 minus theta is the angle between current density and the planar area. Please remember that very well. Mistakes should not be committed in the exam. Keep studying, keep growing.